Hello everyone. We discussed the concept of capillary pressure in previous slides. We discussed also the how the pores will be filled with water and how much of the pore volume can you displace. For example, if you have initially water inside your pore and you have different pore sizes, if you push oil with a certain pressure, which we call it displacement pressure, which pores can be the water of those pores could be completely displaced. Some of the pores, the water inside those pores could be partially displaced, and some of the pores you cannot really displace any water from those pores due to capillary pressure that is more than the pressure that you're injecting. And you can see that those pores are usually the smallest pores. We're talking about a water wet system, so the adhesion tension of water to the surface of the pores are higher than whatever you're injecting in. So that brings us to the concept of mixed wettability. Remember, we discussed this concept in previous videos, and the meaning of that mixed wettability was that part of the reservoir, which are smaller pores, are water wet, and the larger pores are oil wet. The reason for that, if again you look at this picture, you see that during the migration process, when the oil and gas are formed in the source rock, oil and gas migrates upward into the reservoir rock and then try to displace the pores that were initially saturated with water. So that's a displacement process that is happening when the reservoir a petroleum reservoir is being formed, right? So the oil moves up, and that is due to the buoyancy force that exists. And if that buoyancy force is not enough, which is not in most cases, it cannot displace the water inside the smaller pores, right? So the water stays in the smaller pores. However, that oil could displace the water out of the larger pores inside our trap or reservoir rock. Now, when the oil comes here, although initially you have water on the surface of the pore attached, but as time passes and the oil flows here, the thickness of the water layer inside the larger pores will become smaller and smaller, and finally the oil can directly contact the reservoir rock, and due to some chemical reactions, the chemistry of the surface of your rock will change from a water wet to oil wet rock, and that's why in larger pores you will have a oil wet rock. However, you can see that since the oil couldn't displace the water in smaller pores, those pores remain water wet inside your reservoir. So you will have larger pores to be oil wet, and smaller pores are water wet rocks. So that's why you have a mixed wettability in the reservoirs. And this is an example. You can see that larger pores, you have oil inside the reservoir. This is a water wet system. Basically, you can see the water are attached basically everywhere inside the system to the rock, and then you have oil in the middle. However, in the mixed wettability, you can see that the larger pores are filled with oil, and there is almost no water on the surface of those pores. However, the smaller pores are filled with water, right? An oil wet system, of course, you have oil layer on the surface of the pores, and the water would be in the middle. So let's talk about an example, but I'm gonna stop this video, and I'll talk about it in next video.